My dear students, welcome to Easy BTech, your guide for BTech and beyond. This channel is helpful to you to understand BTech subjects very easily. Please subscribe, share the channel, and also watch the subject videos continuously. Today's today's topic is analogy between vectors and signals. Let's start this topic, analogy between vectors and signals, which is a very important topic for JNTU examination. So we discuss now what is this topic. First of all, vector we will see what is vector and examples of vectors. So vector is a quantity. What is vector? It is a quantity that has both magnitude and direction. The quantity which has both magnitude and direction. Both magnitude and direction. Magnitude and direction. This is the meaning of vector. If you see examples, the regular examples, force is vector quantity. Okay, velocity is also vector quantity. They have magnitude and direction. And acceleration, displacement, acceleration, etc. Okay. Now here what we are going to discuss about vectors is orthogonal vectors. What is the meaning of orthogonal vectors? Okay. And how to express one vector in terms of another vector. We take two vectors. How to write one vector in terms of another vector. Approximation of V1 in terms of V2. Like V1 is the first vector, V2 is another vector, second vector. That we are going to discuss. So consider two vectors. Let's take two vectors. Two vectors V1 and V2. The first vector is V1 and the second is V2 as shown below. Here I am showing how we are taking that V1 and V2. This vector is V1 and this is V2, and the second diagram V1 and V2 again I am taking. In third diagram V1 and V2 again I am taking. So three cases I am showing here. This vector is V1 and it is V2. Here also V1, V2, same V1, V2. So now the point is V1 in terms of V2. We are going to write V1 vector in terms of V2. In terms of V2. Or we can say approximation of V1 using V2. Approximation of V1 using V2. So how to do that V1 in terms of V2? So this is the way. So I am drawing a line, a dotted line from the end of V1 to V2. From the end of V1 to V2. Why I want to write V1 in terms of V2? That is why I am taking a line from the end. This is the end of V1 to V2. So this is the one possibility. This point I am taking as C1 into V2. So this is the figure 1 or figure A. So in figure A, how to express V1 in terms of V2, and this dotted line I am taking as error vector V. Error vector V. So V1 can be written as C1 V2 plus error V. This is the way of writing in this figure. Okay, and in the second case I can also draw error vector, which is a dotted line from the end of V1 to V2. This is also possible. So here I am taking it is C2 V2 and this dotted line is error vector V. So from figure B, this is the second figure or second case. Here V1 can be written as, how to write V1? C2 V2 plus error vector V. And in the third case, I am drawing again dotted line from the end of V1 to V2. So this is a perpendicular line in the third case. Perpendicular line. This is V. So I am just drawing a perpendicular from V1 to V2. Okay. Now this point I am taking as C1 to V2. C1 to V2. Now V1 from the figure C or from the third figure, we can say V1 equal to C1 to V2 plus VE. So many ways are possible like this to express V1 in terms of V2. How to express? From the end of V1 line on to V2. From the end of V1 line on to V2. From the end of V1 line on to V2. So infinite methods or infinite ways are possible. But out of infinite methods, out of three, here I am taking three cases. Which is the best method? How can we decide? First one we have to follow, or second one we have to follow, or third one we have to follow? That is the question here. So the best method is, in which method we have minimum error? In first method we have minimum error, or in second method we have minimum error, and in third method we have minimum error. That is the best method of approximation. That is the best method of approximation. If you compare 1, 2, 3 or figure ABC, the third figure is the best approximation because error is minimum here. Error is minimum. That is a point. Minimum error we consider. Right? If you have error is more, it is useless, meaningless of that method. So the best method of approximation is draw a perpendicular. Draw a perpendicular from the end of V1 to V2. End of V1 to V2, which will be the best method of approximation. So this is the best method of approximation. V1 is equal to C1 to V2 plus error or VE. In this, error is minimum. So we consider the third figure out of many possibilities. That is a point here. Now, next thing. So vector V1, what we have? C1 to V2 plus error vector VE. So here this one is called C1 to V2 is called component of or projection of, you can tell, component of V1 along V2. Component of V1 along V2. That is the meaning of C1 to V2. And V is the error vector. V is the error vector, which must be minimum. That is important. Which must be minimum. Right? Clear? Now, how to do this component of V1 along V2? So we can do this using dot product. So C1 to V2 is equal to V1 dot V2 by V2. Component of V1 along V2 is equal to V1 dot V2 by V2. Then by this I am writing C12. What is the value of C12? C12 is V1 dot V2 by this V2 comes here, so V2 square. V1 dot V2 by V2 square. This is the value of C12. Why we are discussing about C12 value? Because using or the value of C12, what it indicates, why we have to do, that reason I am telling. The value of C12, the value of C12 indicates similarity between two vectors. Similarity, the value indicates C12 value, what it indicates, how they are similar, how much they are similar, 10% similar or 20% similar or likewise. So similarity between V1 and V2. V1 and V2. Okay. If C12 value is equal to 0, for example, I am taking case if C12 is equal to 0, means no similarity, they are dissimilar. Okay, C12 is equal to 0. See here, you can take C12 value 0, means the dot product C12 0 means what? That is dot product V1 dot V2 is equal to 0, right or not? That is C12 is 0. The dot product of two vectors is 0. When the dot product is 0, when the dot product will become 0, actually what is the meaning of dot product? V1 dot V2 is equal to V1 V2 angle between them cos theta, right? So here V1 dot V2 0, that means that depends upon theta. So theta value how much? By this theta is equal to 90 degrees or pi by 2 radians, right or not? 90 degrees. So whenever the angle between two vectors is 90 degrees, then the C12 value 0, then dot product is 0. All are same meaning. And what you understand, dot product is 0 means they are called now orthogonal vectors. They are called, because dot product is 0, they are called orthogonal vectors. This is the word we say, orthogonal. Orthogonal vectors. So what is the meaning of orthogonality or orthogonal vectors? The dot product is 0. That is the clarity. Okay, right? So the same concept, orthogonality concept, we are going to see for signals. In case of signals, here we have taken two vectors V1 and V2 and we written V1 in terms of V2 with minimum error. And we have seen formula C12, V1 dot V2 by V2 square. And C12 value indicates the similarity between V1 and V2. Suppose the case C12 is 0, V1 dot V2 will become 0. Dot product is 0 means angle between them is 90 degrees. Angle between them 90 degrees we can call as orthogonal vectors. That is orthogonality in vectors. The same orthogonality concept we are going to apply for signals. Orthogonality in signals now. The topic, the same orthogonality we are going to see in signals. In signals. Right? Now consider two signals like two vectors. Consider two continuous time signals. Okay? Two continuous time signals. Time signals x1 of t, x2 of t. What are the two signals? First one is x1 of t and second is x2 of t. Now I want to write x1 in terms of x2. Approximation, this is, we can say, approximation of x1 using x2. So how to write is x1 of t is equal to the same c12 into x2 plus error signal here, xe of t. This is a way of writing x1 in terms of x2. But this writing in this expression or in this approximation, we have error signal. This error must be minimum. Please remember, we should have always error minimum. Then only it will become best method of approximation. It will become correct. It must be minimum. Okay, this is the point. Remember, minimum error. Now, in this way we can do. But what about C12? How to calculate C12? Here also C12 indicates what? C12 indicates what is the importance of C12? The value of C12, importance of C12 indicates similarity between x1 and x2. The same we discussed in vectors. The value of C12 indicates similarity between two vectors. Here the value of C12 indicates the value of C12 is similarity between x1 and x2. Two signals. Similarity between x1 and x2. So now the point is determination of C12. That is the point. How to determine C12? The formula of C12 to determine C12. How to do C12? With minimum error. Please remember, minimum error. So simple it is. For doing C12 or determine C12, I consider mean square error. And here we have done approximation of x1 in terms of x2 over certain time interval, over limited time interval. That is also important. Approximation of x1 in terms of x2 over interval t1 to t2. T1 to T2. This is the time interval T1 to T2. Now our thing is to determine C12. So to determine C12, I am going to take one point here. What is that? Mean square error. Mean square error. Mean square error. I am denoting this mean square error as epsilon. Epsilon is equal to 1 by T2 minus T1 integral T1 to T2 mod xe square dt. Or xe error square. See here, mean square error square and mean. So integration and dividing by the interval T2 minus T1. It is the mean square error epsilon. So here I am going to do this mean square error. So 1 by T2 minus T1 integral T1 to T2 integral T1 to T2. So here xe means error. So this xe we can write as x1 of t minus c12 into x2 of t, right or not? By the approximation, by this approximation, xe will become, so first write here xe, then we take the substitution. xe is equal to x1 of t minus c12 x2 of t. So this I am going to take now. x1 of t minus c12 x2 of t square is as usual dt. So this is the mean square error, right? Now we are going to do c12 value with minimum error. Error must be minimum. So how it is obtained? In the next page we discuss. So to get or to obtain c12 with minimum error, do this. Differentiate mean square error with respect to c12. So that is d by dc12 of mean square error and equate to 0. In this process we get the c12 with minimum error. So differentiation of epsilon. Epsilon means mean square error. It is a mean square error. MSE with respect to c12 and equate to 0. So this we are going to do now, right? So which is equal to differentiation d by dc12 of mean square error. What is the mean square error? 1 by t2 minus t1 integral t1 to t2 x1 of t minus c12 into x2 of t, c12 x2 of t whole square dt. Then the total is equated to 0. So here 1 by t2 minus t1, if you send it right side, 0 into t2 minus t1. So t2 minus t1, it will become into 0, therefore 0. Next, before going to differentiation, in the bracket we have square. We have like a minus b whole square. It is like a minus b whole square. So I am going to expand that. So integral t1 to t2 a square, that is x1 square, plus b square, that is c12 square x2 square of t, minus 2ab, so 2x1 of t c12 x2 of t, c12 x2 of t, just expansion of a minus b whole square dt. The total again is equal to 0. Here we have three terms. The first one x1 square, the second one c12 square x2 square, and third one minus 2 x1 of t into c12 x2 of t. Now apply the differentiation now. Do the differentiation. What is the first term differentiation? D by dc12 of and here integral t1 to t2 dt. What is the differentiation of first one? 0, because there is no c12 term here, that is why it will become 0. Okay, so first term is 0, and second term, here we have c12 square, here we have c12 square. So differentiation of c12 square with respect to c12, it will become 2c12, and integration is as usual. So integral t1 to t2 x2 square of t dt. Next, third one, differentiation of this third term with respect to c12. So c12 is here, so c12 differentiation 1. The remaining term, what is the remaining term? Minus and integration same t1 to t2 x1 of t into x2 of t dt. The whole is equal to 0, total is 0. Just a simplification, next thing. So here we have 2c1 to integral t1 to t2 x2 square of t dt. Okay, it is equal to integral t1 to t2 2 already there, I am taking as it is, x1 of t into x2 of t dt. So both sides we can cancel 2. Now we can write c12. What is c12 formula? So integral t1 to t2 x1 of t into x2 of t dt divided by integral t1 to t2 x2 square of t dt. So this is the formula of C12. This is the formula of C12. Very, very important for doing problems. This is the formula of C12. Now the case is, if C12 is equal to 0, same like we discussed in vectors, if C12 is 0, how C12 will become 0? If C12 is 0 means that is the numerator integral. What is the numerator integral? Integral t1 to t2 x1 of t dt x1 of t into x2 of t dt is equal to 0. That is the meaning of C12 is 0. Right? So what we say this condition, integral t1 to t2 x1 of t x2 of t dt is equal to 0, means the two signals, if the integral product, integral and we have product, integral product of two signals over the intervals t1 to t2 is 0, means they are orthogonal functions or orthogonal signals over the interval t1 to t2 only, not for minus infinite to plus infinite. We are checking orthogonality of two functions, one t1 to t2. Suppose t1 is a 9, t2 is 9, 5. So 9 to 9, 5 we are checking orthogonality between x1 of t and x2 of t over certain interval. So then x1 of t, this condition, what we call x1 of t and x2 of t, what we call, are orthogonal. They are, we said, orthogonal over interval is also important here, over the time interval t1 to t2, t1 to t2. This is the important point. So to check the orthogonality of two signals, how to check? This is a condition. The integral product, here we have integration and we have product of two signals. That answer is 0. If you do this integration, if you got answer is 0, then they are orthogonal functions or orthogonal signals over t1 to t2. Over t1 to t2. That is the point here. Okay? Right? So this is the session today. We are stopping here. We have next session, the same concept, continuation. We'll meet again. Thank you. Thank you all.